Hello there. Welcome to Static Routing Demo. So for the demo outline, static routes are commonly implemented on a network. So this is true even when there is a dynamic routing protocol configured. So static routes can be configured for IPv4 and IPv6. Both protocols support the following types of static routes. So you've got the standard static route, the default static route, the floating static route, and the summary static route. This video demo is divided into 8 sections. So we've got a separate video demo for standard static route for IPv4 and IPv6. We also have 2 demo for the default static route for IPv4 and IPv6. Same thing with the floating static route and the summary static route. So all in all, we have 8 video demo for these types of static routes. Now, on the course of the video demo, so next hop options were used. So when configuring a static route, the next hop can be identified by an IP address, the exit interface, or both. So how the destination is specified creates one of the 3 of the following types of static route. So you've got the next hop route, wherein only the next hop IP address is specified. You also have the directly connected static route, wherein only the router exit interface is specified. You also have the fully specified static route, wherein the next hop IP address and the exit interface are specified. So either of these 3 are used in the course of the demonstration. If you want to have a complete detail about the IP addressing or IP static routing, you could go ahead and check the video lecture on the IP static routing. So welcome to the first demo, the static routing demo in IPv4 Standard Static Route. So this would be the topology considered on this video demonstration. Let's move on to the demo. Okay, so this would be our topology for this video demo. And let us identify first the networks and the IP addresses to be considered on this video demo. Now, this topology comprises of 3 router configurations. So you've got R1 here, R2, and R3. Okay? So first, we are going to identify the networks connected to R1, and these are 172.16.3.0, 172.16.2.0. Okay, that is for R2, we've got 1.0, 2.0, and 192.168.1.0 here, /24. Now for R3, we have this 192.168.1.0 and 2.0/24 directly connected to it. Alright, so even though this topology is used for IPv6 also, so we have a dual stack configuration. And this, we are going to start with an IPv4 IP assignment on this topology. Okay, so we have not yet configured any, alright, so on these routers here. So let's start with IPv4 assignment. So let's start with PC1. Okay, so we will be assigning the second usable IP on PC1. So we could go to desktop and IP configuration here. So let us assign an IP address. So this one would be 172.16. All right, so .3.2. So subnet mask would be /24. So that would be 255.255.255.0. So our default gateway from the topology is the first usable IP. So this would be 172.16.3.1. All right, so that would be our default gateway. Okay, close. So for PC2, we could go ahead and configure it also. IP configuration for PC2 would be 172.16.1.2. Okay, so as shown on the topology. So our subnet mask is /24, so that would be 255.255.255.0. So the default gateway here would be .1, first usable IP is assigned to our default gateway. So this would be 172.16.1.1 here. All right. Next, so for PC3, let us assign an IPv4 address to this. So that would be on IP configuration here. Okay, so this would be 192.168.2.2. Okay, subnet mask is /24. Okay, and the default gateway is the first usable IP, which is 192.168.2.1 here. All right, so this would be 2.1. All right, so we're done with the IP assignment on these three pieces here. Now let's move on to the router. So let's start with R1. Okay, so let us configure our R1. Okay, so let's give it a name. So enable configure terminal. Okay, say this is host name R1. Right, now let us assign an IP address on these interfaces. So let's show the interfaces here. All right, let's go back to R1. So let's start with the G000. So interface G0/0/0 here. IP address. Okay, so this would be 172.16.3.1. All right, so 255.255.255.0. Okay, and then no shutdown. Right, so the next thing here is to configure serial 010. So let's do it. So interface serial 0, 1, 0. All right, so IP address, that would be 172.16, okay, .2.1. Right, so based on our topology. And this is 255.255.255.0, which is this last 24. Okay, and then no shutdown. Okay, so we're done with R1. So also during the configuration, so observe that we have here our indicator. So if it is green, that means it is connected. Okay, so for the serial 010 of R1, it's still in red because we have not yet configured. So the other end, which is on serial 010 here. So let us now configure R2 for IPv4 assignment. So let us display the interfaces here. So this is also serial 0/0/0. And this one here is serial 011. So let's configure R2 now. All right, so enable configure terminal. Okay, so let's give it a name, host name R2. Okay, so for R2, let's start configuration with the Ethernet. So that would be interface G0/0/0 there. All right, so IP address, this would be 172.16.1.1. All right, so 255.255.255.0. Okay, no shutdown. All right, so next would be interface serial 0/1/0 there. Okay, so this is what we're going to configure. Let's put an IP address on it. So IP address 172.16.2.2. Right? So 255.255.255.0. Okay, and then no shutdown. So if you will observe, this is now green. So that means these two here are physically connected. All right, so let's configure serial 011 here. Okay, so let's move it on the other side here so that we can see the IP address. So that would be interface serial 0/1/1. All right, so IP address 192.168.1.2, 255.255.255.0. All right, so no shutdown. So we're done already with all the IP assignments or IPv4 assignments on R2. Let's go ahead and configure on R3. Okay, so CLI, configure this. So enable, configure terminal. Let's have host name. All right, this is R3 here. Okay, and let's do the IP assignment. Let us display the interfaces here. Okay, and configure R3 now. So you've got interface G0/0/0. IP address. So this would be 192.168.2.1. All right. So 255.255.255.0. No shutdown. Okay. So we're done with the R3 LAN here. Next would be serial 011. Okay. So interface serial 0/1/1 here. So IP address, this would be 192.168.1.1. All right. So 1.1 255.255.255.0. All right. And then no shutdown. Okay. So it is now up. Okay. So all of our interfaces are green. Okay. Just to make sure before we test it, you could click this, okay, fast forward time so that it synchronizes faster. All right. So let's test our connectivity here. So we can use this add PDU here to test the connectivity and check the status on this area here. Okay. Now let me click add simple PDU from PC1 to R1 since this is directly connected. So we have successful here. Also, from router 1 to router 2, which is directly connected also. And then from router 2 to the computer, okay, so successful. All right, so we just need to test the directly connected networks if they are really connected. Okay, so next would be from router 2 to router 3. So these are directly connected. And then from router 3 going to PC3. Okay, so successful. All right, so you just have to click this for this topology to fully synchronized. All right, so now that we are done with an IP assignment, we can now proceed with static routing. All right, so now that we are done with an IPv4 IP assignment on these devices, okay, including PCs and routers, so the next thing to do is to perform standard static IP routing configuration. Okay, so our objective here is to provide full network connectivity amongst PCs here. So we should be able to ping PC1 to PC2, PC2 to PC3, and PC3 to PC1, and vice versa. All right. So right now, we can only ping directly connected devices. So if you are going to ping, for instance, from PC1 going to PC2, so that would be a failure, or that is a failed. All right. So same thing with from PC2 to PC3, it's also a failure. Okay. And so with PC3 to PC1. So that is because we have not yet configured our static routing. Okay, so to start with the configuration, let's first evaluate, okay, so the routing table of each of the router here. So let's start with R1. Okay, so we could type in here, enable show IP route. So if you will observe, only directly connected networks can be seen on the routing table. Okay, so there are two directly connected networks on R1, and these are 172.16.3.0 and 172.16.2.0. Okay, so let's do the same on R2 here. Okay. So let's have show IP route on R2. All right, so enable show IP route. Okay, so from here we can see we have 3 directly connected networks. Okay, so on R2. Okay, and also we do the same on R3. Okay, so on R3, show IP route, this would also display directly connected networks only. And that is, or these are 192.168.2.0 and 192.168.1.0/24. So in other words, we don't have yet routing. Okay, now let us configure routing now. All right, so let me start with R1 here. Okay, so to configure IPv4 routing, okay, so we could go ahead and configure it via configure terminal. Okay, so the syntax would be IP route, all right, and the remote networks. Okay, so take note that from R1 we have 3 remote networks. So these are 172.16.1.0, 192.168.1.0, and 192.168.2.0 here. Okay, so let us configure that. So IP route, let's start with 172.16, all right, .1.0. Okay, so 255.255.255.0. So the next one would be, we have to specify the next hop IP address. All right, so let me use the next hop IP address here. The next hop IP address to reach 172.16.1.0 is via this 172.16.2.2. So that would be 172.16.2.2. All right. So we have now route going to 172.16.1.0, and that is via 172.16.2.2 here. Okay, so that is using the next hop IP address. So take note that we can also use the exit interface. Okay, so the thing is, the exit interface should only be used if you have directly connected devices, or you only have 2 point-to-point devices connected to each other. Like for instance, using serial cable between these 2 routers here. Okay, so that's the only thing that we can use, all right, or the only instance that we can use exit interface. So let me use an exit interface and find out later on as we evaluate the routing table. Okay, so the difference between using the next hop IP address and the exit interface. So to reach 192.168, all right, so 1.0 here, I'm going to use the exit interface instead. All right, so that would be IP route 192.168.1.0. Okay, so this would be 255.255.255.0. Okay, now take note that from the topology, that's to reach this 192.168.1.0/24. So our exit interface from R1 would be this, all right, and this is, or this network is serial 010 there. Okay, so let me use, instead of the next hop IP address, I'm going to use the exit interface, which is serial 0/1/0 there. Okay, so take note that you have this warning. Okay, so default route without gateway, if not a point-to-point interface, this may affect or may impact performance on the network. So you have to ensure that you are using only point-to-point link here. For instance, router 1 and router 2 connected via serial interfaces. All right? Next. So also, we need to specify the third network. Okay, the third network from R1 is this 192.168.2.0 here. So let me use that. So you'll have IP route. All right. So 192.168. All right. .2.0. So that would be 255.255.255.0. 192.168.255.255.0. So take note that we can use also a fully specified network. Okay, so when you use the fully specified network, okay, so you could have both the exit interface and then the next hop IP address. So what we can do with this is, of course, we combine it. Okay, so let me use the next hop IP address here, which is 172.16.2.2. All right, followed by the exit interface, which is serial 0/1/0. So this is what you call a fully specified network. Okay, so we specify the exit interface via serial 010 and the next hop IP address via 172.16.2.2. Okay, so let me use here. It's not working here. All right. So it's not supported here, but then okay, it should be working. So say, okay, so take a look at forwarding. All right, so it's not working on Packet Tracer, the fully specified network, but we can do it. All right, so in the actual setup, so it's just that in here it's not working. So let me just use 172, okay, .16.2.2. But then before that, let's try the serial interface first, or the exit interface, which is serial. All right, serial, what is that? 0, okay, 1, 0, 172.16.2.2. Is it working here on Packet Tracer? No. So it's not possible in Packet Tracer. But then in the actual configuration, we can do this, the fully specified, okay, network. So for now, let me just remove my exit interface here and use the next hop IP address instead. All right. Now, so we are done with defining the 3 remote networks from R1. So let's see the routing table. So you could go ahead to show run or do show IP route here. Okay, and we can see we have 3, okay, directly connected or remote networks specified by S here. Now take a look at the difference between the exit interface and then the next hop IP address. So take note that 172.16.1.0 here, which is the network, okay, or the LAN of R2 here. Okay, so we configured it with the next hop IP address. And if you will observe, stated here in the routing table that to reach 172.16.1.0/24, you could go ahead and check via 172.16.2.2. Take note that 172.16.2.2 belongs to 172.16.2.0, which is directly connected via serial 010 here. All right. So take note that in here, okay, we are referring to the routing table twice. So first, if there would be packet destined for 172.16.1.0, you have to refer to this on the routing table. And from the routing table, it says that you can reach this network via 172.16.2.2. And 172.16.2.2 belongs to 172.16.2.0, which is directly connected to serial 010. So when you use the next hop IP address, your router performs a reflexive lookup, wherein it has to refer to the routing table twice before forwarding the packet to the exit interface. Okay, so that's the use of the next hop IP address. Now take note that on 192.168.1.0, which is the network between R2 and R3, okay, we configured it with exit interface. And if you will observe here on the routing table, it says that if there would be packet going to 192.168.1.0/24, it will be forwarded directly to serial 010. So you have to refer only to the routing table once. All right, so but then take note, the exit interface utilization is good only if you have a point-to-point link between 2 routers or via serial cable. All right, so same thing. I have configured 192.168.2.0 here, okay? So, which is the LAN on router 3 using the next hop IP address, and therefore it has to refer again to the routing table twice. So we call it reflexive lookup. So if there would be packet for 192.168.2.0, that would be forwarded to 2.2. That belongs to 2.0 and then forwarded to serial 010. Right? So that's the difference between the use of the exit interface and the next hop IP address. So, but then unluckily, so we're not able to perform here a fully specified connectivity. Okay, so using both the exit interface and the next hop IP address. Okay, so it's not supported in Packet Tracer, but in reality, you can do that. All right, so the fully specified, okay, network or the fully specified next hop and exit interface combined into one. All right. So now we're done with the static configuration on R1. Okay, can we now ping the or PC2? The answer is still no. This is still a failure because when you forward or send packet to the remote networks, okay, so there is what you call a reply, okay, sent from the recipient going back to the sender to complete the cycle for the communication. Okay, and if we are going to evaluate it, okay, let me show you. Okay, so let's go on simulation. Okay, you can use this test. Okay, click on simulation. Right, so real time. Okay, so let me clear all of this and simulation. All right, so I want you to observe. Okay, so when I ping from PC1 to PC2, okay, so take note that we already have a route on R1, right? So let's go back to R1. Okay, so we already have a route going to 172.16.1.0 here. Okay, so therefore we can reach, or this packet here can reach already PC2. But we are expecting that the reply of PC2 will not be able to reach 172.16.3.0 here. Why? Because on router 2, we have not yet, okay, configured static routing. And therefore, when we type in here, the show IP route, we don't have link going to 192 or 172.16.3.0 here. Okay, so that's what we are expecting with this simulation. So let me press play here. Okay, you've got packet to the switch, right? And then going to router 1. Okay, from router 1, take note that we have the route going to 172.16.1.0. So it will be forwarded to R2 here. And then from R2, the destination is in here on the routing table. It will be forwarded to the switch and then to the PC2 there. All right. So, but then take note, to complete the cycle, the reply, okay, should be able to reach the source. In that case, once it was forwarded to R2, R2 doesn't have a route going to 172.16.3.0. So if you'll observe here, the packet was dropped. All right. And therefore, you're gonna have here a fail. Okay. So when you test this, okay, and go back to real time, so basically it's a failure. Okay. Now, let us configure R2 now for static routing. So to do this, okay, so let's start with configure terminal. Okay, so IP route. Okay, so let's define first 172.16.3.0. So when you configure static routing, you are configuring the remote networks. Okay, so like for instance in R2, take note that 16.3.0 here is not directly connected to R2. So that's what we're going to define on the IP route statement, the remote networks. All right, so 172.16.3.0 followed by 255, the 255.0. Okay, again, we have the option to use either the exit interface or the next hop IP address. So let me just use the next hop IP address here. And that would be 172.16.3.0. 2.1. All right. So we already have the route going back to R1, okay, or from PC2 going to PC1. Okay, so let us complete the configuration here. Okay, so also let's configure route going to, okay, so IP route going to 192.168.2.0. Okay, so 255.255.255.0. And the next hop IP address here would be 192.168.1.1. So that would be 192.168.1.1. All right. Okay. Now we can now check the routing table for R2. So you could have do show IP route. So we are expecting that there is already a route going to 3.0 here, and also a route going to 2.0. Okay. Now this ping here should now be able to connect or establish connection. So it should be successful. Let's double click this. All right. So it is successful now. Okay. So that means we can now ping from PC1 to PC2, okay, and PC2 to PC1, but not from PC2 to PC3, nor PC1 to PC3. Okay. Now, completing the simulations that I presented earlier. So take note that without configuring R2 for the static route, going back to this 172.16.3.0, the reply, okay, is being dropped by R2, okay, since we don't have an entry for 172.16.3.0. Now let's do the same that we already have completed this. Okay, so let me ping from this. Okay, so let's move on simulation. Okay, so let's do that again. Okay, so ping from here to here. Play. All right, packet to R1. Okay, and then from R1 to R2. Okay, so we have an entry on the routing or router 2 on the routing table forwarded to PC2. Okay, so what we care here is the response or the reply. Okay, so which was earlier dropped by R2. So this is now the response. Okay, the reply packet will now be forwarded to R2. R2 now has an entry for 3.0. Okay, so therefore, referring to the routing table, it will be forwarded to R1. Okay, and then from R1, it will be forwarded to the switch and then to the PC to complete the cycle. It will now become successful here. All right, so that's how you use the simulation tool here. Okay, so let's go back to real time. All right, so we're done with the configuration on R2. So the next thing to do is take note that we cannot ping from PC1 to PC3 and vice versa, and also from PC2 to PC3. Okay, so we need to configure R3 for static routing. So let's do it. Okay, now evaluating the routing table for R3. So enable show IP route. All right, so we don't have yet link or route going to the remote network. So what we can see here are just directly connected networks. That is why our ping from the workstations PC2 and PC1 are failed going to PC3. Okay, so let's configure R3 now. So that would be, okay, configure terminal. All right, so IP route. Okay, so let's start with the first remote network, so which is 172. Okay, space 172.16.3.0 255.255.255.0. Okay, so this network here is this one here, 3.0, and our next hop IP address would be 192.168.1.2. All right, so 192 192.168.1.2 there. All right. So also, our next remote network is 2.0 here. Okay. So for 2.0, we could have IP route 172.16.2.0. Okay. 255.255.255.0. The exit interface or the next hop IP address would be 192.168.1.2. Again, you can use here an exit interface if you want to. Okay. And the third one would be this network here from R2, okay, R2 LAN, and that would be, okay, so IP route 192.168.1.0, 255.255.255.0, 192.168.1.2 also. Take note again, you can use here exit interface if you want to. Okay, so enter here. All right. Now, since we are doing the standard static routing configuration, so we are not going to summarize this. But, okay, so if on the next video lecture, okay, we are going to cover the summarization, this could be summarized into a single IP address. Okay, for the meantime, for this demonstration, so we are just using a standard IP address, okay, or IP static configuration. So let's leave it this way. All right, so we are done now with the IP route on R3. Now let's see the routing table. So do show IP route. So we should now have, okay, so 3 SS here. Okay, so which are going to 172.16.1.0, 2.0, and 3.0. So therefore, with this one, okay, so we can now be able to ping from PC1 to PC3. Just double click this. All right, and from PC2 to PC3. So it's successful. All right, so we have now the full connectivity of this network here. Okay, so wherever you ping, whatever you want to ping, as long as that is active and part of this network, then you should be able to establish connection. All right, so that is our video demo for the standard static routing configuration. Okay, and this one is good for IPv4. Now, the next video demo is for IPv6. Okay, so you could go ahead and check it out. So thank you very much for watching and listening. Have a great day.